Good afternoon, everyone. I'm Maxim, and this is Jim and Alex. We're coming from NIST. Today, we're going to tell you about our process for evaluating machine learning systems and how OpenStack helped us a lot in this process. So first thing, a little bit of background. Our team, our job is basically to evaluate data science algorithms from machine translation to speech recognition, image recognition, video processing and stuff. So what we do is we usually have an external entity that contacts us and say, hey, we want to organize an evaluation to determine who has the best speech recognition algorithm, for example. So what we do is at NIST, we set up an evaluation where we call out for performers. That can be companies, that can be researchers. They all have their own solution. And what we do is we evaluate their solution, and at the end, we have a report to say who has the best solution. So our work has been focused on algorithm to process, to recognize activity on video footage. So this is what the evaluation model looked before. So we collected and sent out some annotated videos that the performers would use as a training base. And around that, the performers would develop their solution and produce a system output on a test set we would send afterwards. Once we receive the system output, we score it, and we determine the score at the end. And that's how we used to evaluate the performer systems. So this process has a lot of caveats. So first, data collection is very costly because those data have to be annotated. In the case of video analysis, for example, we have to do manual annotation, but it's also the case in most applications. Then datasets can be very large. It could be terabytes of data, so not everyone has a fiber connection, so it can be hard to distribute. And also it could be confidential, so not for public release. Also, the systems, we have no control over them, so we can't rerun them, we cannot monitor how well they did, and we have to trust that the system output we received is basically coming from the system. We don't have any proof around that. And then we also don't want the system to be overfitted to our data sets. We want the system to be a general purpose system and not just a system fitted to our specific evaluation. So this led us obviously to switch from system outputs delivery to a direct systems delivery, where instead of getting system output, we would ingest their system. Alex is going to talk about that.
So this contrast led us to create a new evaluation model based on system delivery. So now we collect the data sets, but we only provide performer with subset of the data sets. So it's called validation sets. And these ones are used by performer to develop and test the systems before submitting to us the system. So a submission may take the form of a container, a snapshot of a VM, an archive. And so we have a validator that just makes sure the systems are working by running them over the validation set. And if they don't pass the validation, logs are sent back to the performer so they can improve their system. And once we have validated systems, we just run them over evaluation datasets, so it's private datasets that we have to get system outputs that can be scored, like in the previous model. So in this new model, how do we guarantee and deliver system will run in-house? So first, the performer have to make sure the system are working over the validation set, and then we do the same process in-house, and we compare the results to make sure the system are reproducible. And additionally, we may give performer access to the hardware through a VPN and may use the OS virtualization or full virtualization like containers or VMs to get rid of dependencies and configuration hassle. And then we are able to run the system over the evaluation dataset, but it may demand a lot of time to process the system manually if we have a lot of systems and a lot of datasets. So we have to automate these tasks by schedule automatic jobs to run system using a standard CLI calls. So in this context, we also provide performer a standard CLI specification. So it means we just tell performer, hey, we are gonna use this command to run your system with the given parameter. So then the performer have to implement the commands, also called entry point to their systems. And they provide their system within the CLI implementation to us. And we automatically run the CLI implementation and the systems over the evaluation datasets. So we have a standard way to do that. And also, we may have a lot of submission, a lot of systems. So we also use a job scheduler. So job in our context is just a combination of a system and dataset. And executing a job means instantiate a system on a node and give it access to a dataset in a sequestered environment. Then execute the CLI entry points of the performer and reports the logs. And finally, gather and save the system outputs, the logs, and the resource monitoring reports. So this is great, but now we have to see with Jim how we implement this using OpenStack.
Okay, so here's like a basic overview of how our architecture looks. We actually have two environments. One is for the performers to set up their environments. And then once they're set up, we'll bring those in-house and run them on the sequestered data sets. So we use a different project for each performer. And then we use security groups to kind of to isolate them from each other. So we actually have two tiers of performers too. Some we can give VPN access into like our development stack, so they can set up their systems, they can iterate on it. And others we can't trust to do that because of various restrictions we have. And so we actually, they provide us a URL that we then pull in, and it instantiates the systems, installs everything, including drivers, Docker, all that kind of stuff. And then we take a snapshot of that, bring it in-house, and then we have an automated system that will run those on our data sets. And that provides reproducibility as well as timestamps of when this system was delivered. And we use a Cinder backend. Internally, we use Ceph. Externally, we didn't go to the trouble of building a whole Ceph cluster for that small environment. Like I said, we use security groups to kind of secure them. We use Heat as a job scheduler. And so we have actually an in-house job runner that instantiates Heat to build the environments and run the systems. And our performers use GPUs pretty extensively, but we have a cost target for each instance. And so we use 4 1080 Ti's in each system because that gave us the best price-performance ratio. And surprisingly, they've been holding up pretty well. We haven't had too many failures. And so let me start with the cons, basically, is that we need to pay for infrastructure to do this. It's not that costly, but it is an added cost. But the pros far outweigh that. Their data set life is greatly extended. We can use it for additional evaluation specs and all kinds of different things, and we don't have to recollect it and re-annotate it and just spend the money to get more data. And we can also do continuous delivery of systems. So our performers can tweak their systems, and then we can potentially do like a weekly run, see how they're performing better or not as well. Also, automating it optimizes the use. So we don't have to manually run each system, and we can have systems run on specific hosts, so you don't have to reload the image. And so it greatly increases how we use our resources. Also, we can now run these systems on just brand new data. So if we get new data, the performers don't have to know anything about it, and we can just run it on their systems and see how they perform. And so in our first phase, we've had 6 performer machines using this to do activity and object detection on streaming video. We've run it on dozens of hours of video. And currently, we're running it on a prize challenge. So we have a prize challenge where you can actually win money if you are the best performer. I've got the website up here. You can check it out if you're interested. And as far as future stuff, we're going to keep getting more and more data. Our data sets are only going to get larger, so we're going to have to deal with that, as well as have multi-node performer systems so we can scale up one performer if we want to test them more or scale down. But that adds a lot of complexity. Also, we're looking into maybe a new job scheduler. Right now, we're using an in-house job scheduler, a job runner, but we're always looking for different solutions and that kind of thing. So that about sums it up. Here's our emails if you want to contact us. And do you have any questions?
Are you familiar with NVIDIA's restriction on licensing for the GeForce drivers if you use consumer-grade GPUs in a data center? And if so, how are you working around that? And if I should be asking you this not in front of 50 people, should I do that instead?
Yeah, I'll talk to you about it later. Do you have anything? I don't know what he's pointing to.
Oh yeah, and by the way, if anybody has some job offers here, we kind of interested, so feel free to come to us.
All right, thank you very much, guys.